For the past few years, I've been spending my summers in the Marine Biological Laboratory in Woods Hole, Massachusetts. And there, what I've been doing is essentially renting a boat. And what I would like to do is to ask you to come on a boat ride with me tonight. So we ride off from Eel Pond into the Vineyard Sound, right off the coast of Martha's Vineyard, equipped with a drone to identify potential spots from which to peer into the Atlantic. Now, earlier I was going to say into the depths of the Atlantic, but we don't have to go too deep to reach the unknown. Here, barely 2 miles away from what is arguably the greatest marine biology lab in the world, we lower a simple plankton net into the water and bring up to the surface things that humanity rarely pays any attention to and oftentimes has never seen before. So here's one of the organisms that we caught in our net. This is a jellyfish. But look closely. And living inside of this animal is another organism that is very likely entirely new to science, a complete new species. Or how about this other transparent beauty with a beating heart, a sexually growing, on top of his head, progeny that will move on to reproduce sexually. Now let me say that again. This animal is growing asexually, on top of his head, progeny that is going to reproduce sexually in the next generation. A weird jellyfish? No, not quite. I mean, this is an ascidian. This is a group of animals that now we know we share extensive genomic ancestry with, and it is perhaps the closest invertebrate species to our own. Meet your cousin, Thalia democratica. So I'm pretty sure you didn't save a spot in your last family reunion for Thalia, but let me tell you, these animals are profoundly related to us in ways that we're just beginning to understand. So next time you hear anybody derisively telling you that this type of research is a simple fishing expedition, I hope that you'll remember the trip that we just took. Today, many in the biological sciences only see value in studying deeper what we already know, in mapping already discovered continents. But some of us are much more interested in the unknown. We want to discover completely new continents and gaze at magnificent vistas of ignorance. We crave the experience of being completely baffled by something we've never seen before. And yes, I agree, there's a lot of little ego satisfaction in being able to say, hey, I was the first one to discover that. But this is not a self-aggrandizing enterprise. Because in this type of discovery research, if you don't feel like a complete idiot most of the time, you're just not sciencing hard enough. So every summer, I bring onto the deck of this little boat of ours more and more things that we know very little about. So I would like tonight to tell you a story about life that rarely gets told in an environment like this. From the vantage point of our 21st century biological laboratories, we have begun to illuminate many mysteries of life with knowledge. We sense that after centuries of scientific research, we're beginning to make significant inroads into understanding some of the most fundamental principles of life. And our collective optimism is reflected by the growth of biotechnology across the globe, striving to utilize scientific knowledge to cure human diseases. Things like cancer, aging, degenerative diseases, these are but some of the undesirables we wish to tame. But I often wonder, why is it that we are having so much trouble trying to solve the problem of cancer? Is it that we're trying to solve the problem of cancer and not trying to understand life? Life in this planet shares a common origin. And I can summarize 3.5 billion years of the history of life on this planet in a single slide. What you see here are representatives of all known species in our planet. And in this immensity of life and biodiversity, we occupy a rather unremarkable position. Homo sapiens, the last of our kind. And though I don't really want to disparage at all the accomplishments of our species, As much as we wish it to be so, and often pretend that it is so, we are not the measure of all things. We are, however, the measurers of many things. We relentlessly quantify, analyze, and compare, and some of this is absolutely invaluable and indeed necessary. But this emphasis today on forcing biological research to specialize and to produce practical outcomes is actually restricting our ability to interrogate life to unacceptably narrow confines and unsatisfying depths. We are measuring an astonishingly narrow sliver of life and hoping that those numbers will save all of our lives. How narrow, do you ask? Well, let me give you a number. The National Oceanic and Atmospheric Administration recently estimated that about 95% of our oceans remain unexplored. Now, let that sink in for a second. 95% of our oceans remain unexplored. So I think it's very safe to say that we don't even know how much about life we do not know. So it's not surprising that every week in my field we begin to see the addition of more and more new species to this amazing tree of life. This one, for example, discovered earlier this summer, new to science, and now occupying its lonely branch in our family tree. What is even more tragic is that we know about a bunch of other species of animals out there, but their biology remains sorely understudied. I'm sure some of you have heard about the fact that a starfish can actually regenerate its arm after it's lost. But some of you might not know that the arm itself can actually regenerate a complete starfish. And there are animals out there that do truly astounding things. And I'm almost willing to bet that many of you have never heard of the flatworm Schmittea mediterranea. This little guy right here does things that essentially just blows my mind. You can grab one of these animals and cut them into 18 different fragments, and each and every one of those fragments will go on to regenerate a complete animal in under 2 weeks. 18 heads, 18 bodies, 18 mysteries. And so for the past decade and a half or so, I've been trying to figure out how these little dudes do what they do and how they pull this magic trick off. But like all good magicians, they're not really releasing their secrets readily to me. So here we are, after 20 years of essentially, studying these animals, genome mapping, chin scratching, and thousands of amputations and thousands of regenerations, we still don't fully understand how these animals do what they do. Each planarian, an ocean unto itself, full of unknowns. Now, one of the common characteristics of all of these animals I've been talking to you about is that they did not appear to have received the memo that they need to behave according to the rules that we have derived from a handful of randomly selected animals that currently populate the vast majority of biomedical laboratories across the world. Meet our Nobel Prize winners. 7 species, essentially, that have produced for us the brunt of our understanding of biological behavior today. This little guy right here, 3 Nobel Prizes in 12 years. And yet, after all the attention they have garnered and all the knowledge that they have generated, as well as the lion's share of the funding, here we are standing in front of the same litany of intractable problems and many new challenges. And that's because, unfortunately, these 7 animals essentially correspond to 0.0009% of all of the species that inhabit the planet. So I'm beginning to suspect that our specialization is beginning to impede our progress at best, and at worst, leading us astray. And that's because life on this planet and its history is the history of rule breakers. Life started on the face of this planet as single-cell organisms, swimming for millions of years in the ocean, until one of those creatures decided that I'm going to do things differently today. Today, I would like to invent something called multicellularity. And I'm going to do this. And I'm sure it was an unpopular decision at the time, but somehow, it managed to do it. And then multicellular organisms began to populate all these ancestral oceans, and they thrived. And we have them here today. Land masses began to emerge from the surface of the oceans. And another creature thought, hey, that looks like a really nice piece of real estate. I like to move over there. What, are you crazy? You're going to desiccate out there. Nothing can live out of water. But life found a way. And there are organisms now, of course, that live on land. Once on land, they may have looked up into the sky and say, hey, it'd be nice to go to the clouds. I'm going to fly. You can't break the law of gravity. There's no way you can fly. And yet, nature has invented multiple and independent times ways to fly. I love to study these animals that break the rules, because every time they break a rule, they invent something new that made it possible for us to be able to be here today. These animals did not get the memo. They break the rules. So if we're going to study animals that break the rules, shouldn't how we study them also break the rules? I think that we need to renew our spirit of exploration. Rather than bringing nature into our laboratories and interrogate it there, we need to bring our science into the majestic laboratory that is nature. And there, with our modern technological armamentarium, interrogate every new form of life we find and any new biological attribute that we may find. We actually need to bring all of our intelligence to becoming stupid again, clueless in the immensity, in front of the immensity of the unknown. Because after all, science is not really about knowledge. Science is about ignorance. That's what we do. Once, Antoine de Saint-Exupéry actually wrote that if you want to build a ship, don't drum up people to collect wood and don't assign them tasks and work, but rather teach them to long for the endless immensity of the sea. As a scientist and a teacher, I like to paraphrase this to read that we scientists need to teach our students to long for the endless immensity of the sea that is our ignorance. We, Homo sapiens, are the only species we know of that is driven to scientific inquiry. We, like all other species on this planet, are inextricably woven into the history of life in this planet. And I think I'm a little wrong when I say that life is a mystery, because I think that life is actually an open secret that has been beckoning our species for millennia to understand it. So I ask you, aren't we the best chance that life has to know itself? And if so, what the heck are we waiting for? Thank you.